Professor Bob Young, and in this instructional video we are going to look at solving what's called rational equations. Now, rational numbers are numbers that can be written as fractions. So I know this is the thing y'all love the best here. So really, another name for rational equations will be our friends fractional equations. Now, we've already discussed this in earlier parts of the course, so let's just go ahead here. These have a little different twist to them. And in this graphic, we're going to show that a rational equation is an equation that has a rational expression for one or more terms. Now, again, these are going to be fractions. Because a rational expression is not defined when its denominator is 0, values of the variable for which any denominator equals 0 cannot be solutions of the equation. So to solve a rational equation or fractional equations, and we've learned this in earlier parts again, begin by multiplying both sides of the equation by the least common denominator of the equation. So looking at this first example here, we've got 3x minus 1 over 3 minus 2x over x minus 1 equals x, and we are trying to solve this rational equation here. Now, what you have to look at here is the common denominator here is, well, you've got a 3 and you've got an x minus 1. So multiplying these together, the least common denominator is 3 times x minus 1. Now, notice in this problem, if x is 1, the denominator is going to be 0. So in this problem, if we solve for x and we come out with 1, we're in trouble. X cannot be 1, see, because division by 0 is undefined. Now, if you ever have this happen, what you have to do, let's say we do all this work, we get x is 1, you have to say there is no solution to the problem. So the answer must make sense, as in all equations, and it must check. Okay, continuing this example, in pretty blue here, we've got the LCD multiplied through, and I like the way this graphic's looking here because they took that 3 times x minus 1 and put it right out in front of each term of the equation here. Now, also, if you want to, you can put a 1 under all of these with fractions, and see this x on the right side is not a fraction, so we can just leave that alone. Now, notice over here, when we multiply those three things together, the 3, the x minus 1, and the x, you may want to reshuffle some stuff here to get 3x times x minus 1 in this manner. So do you see some chopping action going to happen here when you get rid of these fractions? You can get the Ginsu knives out and take the 3's out there, the x minus 1's out here, and then we'll see on this other side what happens as well. So let's go through the next graphic. And when the 3's go out, and we'll do this one more time in slow motion, you'll be left with the x minus 1 times the numerator of 3x minus 1. The x minus 1's over here will cancel out, leaving you with this 3 in pretty blue times the numerator 2x. And over here, notice they rearranged all of that, as I said there. Now, nothing's going out there because nothing's canceling. Everything's in the numerator, so all of that's going to get distributed and multiplied together here. So that's going to give us 3x squared minus 3x. What did they do to go from here to here? Well, I bet you guessed they FOILed these two together. And also notice up top there, it says solving linear equations that lead to linear equations. Now, I know what some of you may be thinking here. Now, Young, down here on the bottom, we've got quadratic equations. We've got squares in here. But notice what's going to happen. We have a 3x squared down there on the bottom on opposite sides. So when we cancel them or subtract them out, if we want to move the letters, the x squares go out, and we are indeed left, and I'll underline it in green up here, with a linear equation. So these are kind of the nice ones here. And that's exactly what they're showing here when they solve now. So those 3x squares are out of there. And then we're going to go ahead and collect like terms, and we'll go ahead and get the colors out here. So minus 4x minus 6x will give us the minus 10x over on the left here, plus this 1. equals minus 3x. It looks like to me on this one, they took the 10x, they moved the letters to the right on this one, just because it looks a little easier. Now, you could have taken the letters left and the numbers right, but in this case, they just moved, and I'll put here numbers right by adding 10x. So they get the answer of 1/7, and notice this restriction does not affect the result. This restriction, we said x can't be 1 in the start. 1/7 will check if you take it and you're really good with your calculator. I mean, if you're really good, if you put 1/7 in here, 1/7 in here, 1/7 in here, 1 equals 1/7 over here, it will make perfect sense. Guaranteed, or triple your money back. Ta-da! 1/7. Let's go on to another example now. Now, looking at this next example, hopefully no one will miss the common denominator, because not only is it the common denominator, it is the only denominator. So x minus 2 in this case is what we're going to multiply every single term by. And again, when they're fractions, if you want to, you can use colors and everything. I always tell students on these more difficult equations, use colors here. Go ahead and put a 1 under there, so when you start doing some chopping, you will see here. Now notice the forbidden answer in red. What number or numbers make the denominator 0 cannot exist or happen. X can't be 2 here because of what's up top. So be careful on this. So now let's do some chop. The x minus 2's go out, leaving you with this x, as they do here, leaving you with this 2. And then you're left with the rest of this 2 times x minus 2 here. Continuing. Distribute the 2 through up here. And we get 2x minus 4. And then we're collecting some like terms and distributing and so forth. So it looks like over here that they subtracted 2x from both sides. They went ahead and they moved the letters left on this one. So they got x minus 2x is minus x right below it there. And then they took, and I'll use a different color here. I like to use these colors. I hope this helps you. Oops, got a little stray one there. The 2 minus 4 gives you negative 2. So dividing both sides by negative 1, we get x equals 2. But wait a minute, my spider sense is tingling. This can't happen. 2 cannot happen because what? Oh, all of that work. It says the variable is restricted to real numbers except 2. If x equals 2, then multiplying by x minus 2 in the first step is multiplying by 0, which is not valid. And we have division by 0 here. So ladies and gentlemen, I'm sorry, but in this case, all this work for nothing. No solution. So watch and make sure no answer makes any denominator 0. All right, one more example here, and I think that might do it for us in this instructional video. Now, this one's probably a little tougher because you have a denominator on the right side of the equation that factors. All right, and also notice this is going to lead to what is called quadratic equations here. So on this one, if we go ahead and we factor out an x, that's going to give us x minus 2. So looking across at all of these denominators, the LCD is going to be x times x minus 2. So you want to take at least, the most of every single item and multiply it together, and that gives you the common denominator. And if you don't get the right common denominator, all of your fractions won't go out. So notice this one here, all of them are fractions, so we're going to put 1s under there. So when we start chopping, we'll be in good shape. Also, notice the restrictions here. X can't be 0, and x can't be 2. Forbidden answers, it will cause the denominators to be 0. All right, so multiplying through here, and we'll go ahead and we'll pull out the chopping. The x minus 2's are going to go out here. The x's will go out here. And then, boy, look at this one. The x minus 2 and x go out on the right side, leaving us with a very nice quadratic equation. Now notice the x squares are not going out in this example, so these are a little bit more challenging as we move on. So we're going to end up with collecting like terms, 3x squared plus 3x equals 0, which factors very nicely. Now notice on quadratic equations, we've got to get everything equal to 0, so they went ahead and brought the 2 over here, and then they factored. So what are the two answers? Whatever makes one of these creatures 0 is one answer. Whatever makes the other one 0 is the other answer. So notice we have 0 or -1 for our proposed solutions. Now, can both of these be the answer? Because of this restriction, x can't be 0. The only valid answer is x equals -1. So in this case, we got two answers, but only one will check, and that is the answer that does not cause the denominator to be 0. See, because if I put 0 in here, we're in trouble. All right, so sometimes on these ones that lead to quadratic equations, you will get two answers, and both answers will work. Sometimes you may get two answers and only one will work, and sometimes you'll get a couple answers and neither will work. So make sure you plug your answers in and check so no denominator is equal to 0. And here is yet one more example here in solving rational equations that lead to quadratics. So we'll factor this denominator. X squared minus 1 is going to be x plus 1 times x minus 1. And you can see that the LCD here, the most of each item to get rid of the fractions would be 1x plus 1 times 1x minus 1. So they go ahead and they multiply both sides through by that, and look how long this one's getting over here. We put over 1 here, we put over 1 here, we put over 1 here. Now what I'm going to let y'all do is finish this one and then see if you get it right in the next video. Because see, I can work these and work these and work these. So what I want y'all to do is from this step, solve for x, watch your restrictions. Now I haven't told you what x can't equal in this one. You should hopefully figure that out, and we'll pick it up on the next video. See how you do. Solve for x. Okay, Bob Young signing off. See you on the next video presentation.